Today we are looking at a different unit of measure for circle, and that unit of measure is called a radian. So radians, I'll fit that on the line. Are a unit of angle measurement in circles where 1 radian is equal to the length of the radius of a circle. So you can see this picture here. The radian is in the angle, and the radius is our line from center to edge. So we'll be using 3 different pieces. We'll be using the angle, which you'll see marked with a theta. It's a circle with a line through it. That is a Greek letter, theta. Our radius will be the line, and then our arc length will be a different number that it'll show. So those are the 3 pieces: the arc, the radius, and the radian, or the theta. So first, we are going to look at some different pieces. So we are going to move from degree, which is what we're used to looking at, to radians. And then we're going to look at the other way, radians to degrees. So first, we'll talk about degree to radians. So when we look at degree to radians, we're going to use the fraction pi over 180. So pi, this is only used with circles. So as we're working with circles, we will see pi pop up, and then over 180. So here is how this works. So on our example, a central angle of a circle measures 110 degrees. What is the measure in radians? So here it just wants us to go from this 110 degrees to radians. So to make this change, all we have to do is 110 times pi over 180. So when we do this, you multiply fractions straight across, so we get 110 over 180 with pi on top. So our numbers, we can make those smaller. So if I get a fraction on my calculator, I can type in 110 over 180. It says write your answer in terms of pi, so I do not put the pi in the calculator, just the numbers. When I press enter, I get a new fraction of 11 over 18. So for my final answer here, I would have 11 pi over 18. And that's all you do. If you have degree, you multiply by pi over 180. Now on the other side, if we want to go backwards, so instead of going degree to radian, we want to go radian to degree, we just take that fraction and flip it over. So now we have 180 over pi. It's going to be the same idea, just a new fraction. So on our example, it says if the measure of an angle is 3 pi over 2 radians, then what is its degree measure? So for this one, I want to take 3 pi over 2 and change it to degree. So all we have to do is take 3 pi over 2 and multiply it by 180 over pi. So when we do this, we'll get 3 times 180 pi over 2 pi. If we have a pi on top and a pi on bottom, those pi's go away. Then I can put this part here in my calculator. So I can get another fraction, and I can type in 3 parentheses 180 parentheses, and on bottom I can put 2. When I press enter, my answer is 270 degrees. And that's all you have to do, is multiply. If you have degree, you multiply by pi over 180. If you have radian, you multiply by 180 over pi. So now we're going to look at how we can find the arc length. Or if we're given an arc, find the angle. So this is looking at find arc length. So here you can see another picture where R is our radius, we've got theta in our angle, and S, this is our arc that goes around. So we have a formula, an equation that we'll use, which is theta, our angle, equals arc over radius. And we'll use this with all of these. If we have an arc and a radius, they want an angle. If we have an angle and a radius, they want the arc. We'll use this formula. So example number 1. The radius and the arc length are given. Find the radian measure of the central angle. So we're looking for the central angle, we're looking for that theta. Our radius is always going to be the inside line. So here, our radius is 5. And then our arc length is going to be around the curve. So here, our arc length is pi over 3. So in order to find our angle, we want arc. So our arc is pi over 3 over 5. That's a lot of fractions and fractions. So another way that we can write this is we can do pi over 3 times 1 over 5. It'll get us the same answer. So when we do this, pi times 1 leaves us with pi, and 3 times 5 leaves us with 15. And this is our final answer. Since it wanted radians, we should have pi, and we do have pi. So if it asks for radians, you should have pi in your answer. And one more example. Here it says, find the missing arc length. That's not the color we use for arc length. Find the missing arc length given the angle measure and the radius. So if we look, our radius is the line inside. So here it's 11. Our angle measure is in the middle, pi over 2. And then we're looking for our arc. We are looking for this piece right here. So again, we're going to use our formula of our angle equals arc over radius. So if we plug in what we have theta, our angle, is pi over 2. Our arc, we don't know that. So I'm just going to put A. And then my R, my radius, is 11. So how we can solve this? Since 11 is on bottom, I can multiply both sides by 11. Because then I have an 11 on top and an 11 on bottom. So those 11s would go away. And then over here, I can multiply by 11. So what I would end up with is A equals 11 pi over 2. And if you want to check your fraction, we can always put that in the calculator. 11 over 2, and see that it's still 11 over 2. And this is our final answer. All right, if you have questions, if you need help on the practice, please ask me, ask Miss B, find a way to let us know. If for some reason we are virtual and we're on Zoom, put something in the chat. You can unmute and ask a question, but please let us know if you need help. We are happy to help you.